This week, class, we're talking about quantitative statistics and the quantitative analysis part of a research study. Now, of course, when we talk about quantitation, we're talking about numbers. And if you're doing a qualitative study, if you just decided to do a mixed methods, as we've talked about before, where you did both quantitation and qualitative, this is something you would need. This is also, we're going to talk about introducing statistics, which is part of the quantitation. It's how we're going to analyze our numerical data. So basic terminology, cross-tabulations. You see these throughout the week. And I'm not going to go into a great detail within this presentation because I have uploaded, I think, 3 or 4 that really go into the specifics of the statistics. So a cross-tabulation is a technique for measuring association and controlling other variables. I do want to say that you need to be able to recognize this terminology, at least be able to know the differences in these. Descriptive stats are stats that are used to describe or the distribution of and relationship among variables. So it's just, as it is, it's descriptive. Inferential statistics. This is statistics that's used to estimate our degree of confidence that can be placed in generalizing from the sample that you choose to the overall population. So you select your sample from the population, but be able to, in inferential statistics, to infer what you find on your sample to your population. When you're preparing your data for analysis and quantitation, and you've heard me talk about this with coding, especially when I talked about my meta-analysis, and we talked about that before, how you take the information from those studies and you're going to code it into your software program. It's the same thing. Let's say that you took, let's do a simple survey of 10 students outside the student building, and you just ask them, one, are you male or female? That's one question. And so you have male as coded as 1, female as 2. You might ask, what year are you in school? And you would have, choices of freshman is a 1, sophomore is 2, junior 3, senior 4, graduate 5, and so on. So let's say you have those 2. Well, you put them into your analysis, your software, just like that. You would name your first variable. So you name it gender, and you're going to have 1 and 2, 1 male, 2 for female. Then your next column is going to be school, and you're going to do the same thing. You're going to label it 1, 2, 3, 4, 5. That's entering your data into statistical analysis. The data cleaning is really just a backup that you need to check it. It's really good when you're entering your data to do it in a number of different ways so that you double check and check yourself. Univariate distributions. When we're looking at it, we're looking at one variable at a time. So you might run a frequency distribution and graphs of the distributions that will show one variable at a time. And so graphs have the advantage over numerically displayed frequency distributions because it's a picture of overall, and it's easier to comprehend. Distributions are preferable when exact numbers of cases with values must be reported. 3 features when we talk about univariate distributions. We're talking about the shape of a distribution. We look at central tendency. This is the most common value for variables measured at the nominal level. Remember, that's the lower level, or the value around which cases tend to center for a quantitative variable. We're also looking at variability. Remember how these vary across each other. The extent to which cases are spread out through the distribution or clustered in just one location. Skewness, and I've talked about this before in other lectures. It's the extent to which cases are clustered more at one or the other end of the distribution of a quantitative variable. So, for instance, I use the example of sentence length. A lot of times when you look at these data sets, like the survey of inmates in state and federal correctional facilities, they might code a life sentence without parole as 999. So when you run a distribution on that, it's going to skew it way off. So if you're looking at your median, it's going to be way at the other end. A variable's level of measurement is the most important determinant of the appropriateness of particular statistics. As I mentioned a minute ago about our graphs, we have our bar chart, which contains solid bars separated by spaces. These are evident within your textbook. The histogram, it's like a bar chart, but it has bars that are adjacent with no gaps. It's used to display quantitative variables that vary along a continuum, unlike a bar chart where they're more separated and divided. If graphs are misused, they can distort rather than display. In other words, just like we say, you have to be ethical within your analysis. Adhere to the following guidelines when you're constructing a graph. Begin the graph of a quantitative variable at 0 on both axes. Always use bars of equal width. If you use, 5 bars and they're all different widths, it's going to really confuse and throw off your graph. The 2 axes usually should be of appropriate equal length, and avoid chart junk that can confuse the reader. Frequently distributions. You see this a lot, especially within the other presentations that I included. A frequency distribution displays the number, the percentage, the relative frequencies, or both for cases corresponding to each of the variables' values or a group of values. So you'll see numbers, percentages. That's your frequencies. If percentages are presented rather than frequencies, sometimes both are included. You see those within your graphs. You should also look for this within the studies that you have for your research paper. You can see if they are if they have presented both frequencies and percentages. Ungrouped and grouped data. It's constructing and reading frequency distributions for variables with few values is not difficult. If there's too many values to easily comprehend, a grouped frequency distribution can be constructed. In other words, if you have 1,000 variables and 1,000 frequencies of, let's take that back, not 1,000 variables, 1,000 frequency distributions of your variables, then you would have 1,000 columns within your chart, and of course then that's not appropriate, so you would group those together. Grouped data adheres to the following guidelines. The categories should be logically defensible and preserve the distribution shape. Categories should be mutually exclusive and exhaustive. The first interval must contain the lowest value and the last interval must contain the highest. Each interval width, which is the number of values that fall within each interval, should be the same size. Remember how I just said the bars? There should be between 7 and 13 intervals. So the key is not to have so few intervals that data are clumped or clustered into only a few intervals, and not to have so many that the data are not much clearer. Now we're going to move into our measures of central tendency. These are the most frequent values in a distribution that you will see, and many times you will not see all of these listed within your graphs and your tables. Distributions have one mode, which is unimodal, or more than one, which could be bimodal or trimodal. The mode is most appropriate to use when the only measure of central tendency available for variables measured at the nominal level, when the most probable value needs to be determined. So we're looking at that which occurs the most. So there's two potential problems when you're looking at the mode. Some distributions don't even have one, and the mode might fall far from the main clustering of cases. The median is our score point that divides the distribution in half. So let's say you have 1,000 points and scores, and you want to find your median. Well, you can actually count up, 500 and then another 500, but you can also use this formula down here, which is our n plus 1 divided by 2, with n being the number within our sample, which in our case, like I just said, would be 1,000. Now when we look at the median is the score at the 50th percentile. So we can also identify it in a frequency distribution by finding the value that's corresponding to a cumulative percentage of 50. This is inappropriate to use for variables that are measured at the nominal level, so you need numerical values. Now our mean, this is what we think about when we think about an average. So it's the arithmetic average of all scores in a distribution. So to get the mean, you sum up all the values of your cases and then divide by the number of cases, just as you do with an average. So what do you think is more appropriate? And you'll see this sometimes within your studies that you've reviewed, is whether or not to use, do you use the median or do you use the mean? And the key issues to be considered are, the level of measurement that you're looking at, the overall shape of your distribution, and the purpose of your statistical summary. Sometimes it may even be appropriate to use both measures. Talking about measures of variation, this captures how widely or densely spread the values are for the variable of interest. And when we look at our variability, we're going to look at range, our interquartile range, our variance, and our standard deviation. You don't necessarily have to fully understand how to calculate these, but I do want you to understand when you would use these and what they're for. So the simplest is our range. And this is appropriate for ordinal, interval, and ratio levels of measurement. The range of a distribution is calculated as you take your highest level, subtract your lowest level, and that will give you your whole range of scores. So it's the score from whatever you start at. Let's say you start at 10 and you go to 30. Your range is going to be 20, between the 10 and the 20, the 10 and the 30, excuse me. It's often as important to report the range of a distribution to identify the whole span or the range of your values that might be encountered. Our interquartile range, this is the difference between the scores at the first and the third quartiles. So this means that you have divided up your scores in 4 equal sections. And this avoids the problem created by unusually high or low scores. And quartiles are the points corresponding to, as I just said, the first 25, the first 50, then the first 75. So the first and your third quartiles are determined the same way as the median, but by finding the points corresponding to 25 and 75% of the cases. This is just within your research. If when you're trying to really analyze your overall scores, you would want to report this. Now our variance. The variance is the average square deviation of each case from the mean. What I want you to understand there is you don't have to understand how to calculate it, but think of taking each score, subtract the mean, now square the difference, and sum all of these differences. And then divide the sum by your total or the total of number of scores minus 1. This is just the variance among your scores. You don't really, like I said, you don't have to understand how to calculate that. Just understand what it means. Now our standard deviation, you see this a lot, and this can become very confusing. So we can talk about how to calculate it, but like I said, I'm not overall concerned with you knowing how to calculate it, but just that you understand what the standard deviation is, and we're going to talk about that more here in a minute. So the different measures of your different data, and just with the level of variables that you would need, your mode would be your nominal, ordinal, and interval and ratio, so it's all levels. Your median, you can only do it with an ordinal and interval ratios. Your mean, you've got to have numbers, so you can only do it with an interval or ratio, and the same thing with all of your variances. Cross-tabulating variables. I think somebody mentioned this within their discussion. So a cross-tabulation, it displays the distribution of one variable for each category of another variable. So you're looking at bivariate distributions, 2 variables. It's a tool for statistically controlling one or more variables while examining the association. So you're looking at, when you look at a crosstab, you're looking at the associations between variables. And this is usually used when both variables are either nominal or ordinal. So we're looking at more categorical data. Our marginals are the values at the end of each row and at the end of each column. You always see this within a cross-tabulation. As I said, right now, I'm going to reiterate this with this chapter. We are not doing quantitative statistics in this class. We're looking at just the types of variables. So when you're looking at your own research right now, and you're writing your method, you'd like to be able to state what kind of statistics you would use on your variables. And the only thing you really need to know is your type of variables that you're using and what kind of relationship that you want to find. Do you want to find a relationship? So within our crosstabs, we have our cells. They represent the joint distribution of the two variables. So within your text, if you look at that, you'll see your cells where they represent the joint distribution of gender and delinquency. So you're looking at two variables and that distribution. That's what you need to remember. When you are describing association, you want to look at the percentage of distributions. Do they vary at all between the categories of the independent variable? Remember, your independent variable is that variable that does not change. It causes a change in your dependent. So you also want to look at the strength. How much do the percentage distributions vary between categories of the independent variable? These are that which you are looking for within your association. And remember, when you're looking at association, you want to look at how you're describing it. So you're looking at the direction. For quantitative variables, do values on the dependent variable tend to increase or decrease with an increase in the value? So is the independent variable, when that increases or decreases, is that increasing or decreasing your dependent? So you're looking at how your independent is impacting your dependent. Now, you also want to look at the pattern. When you're looking at quantitative variables, are there changes in the percentage distribution of the dependent variable? Or does it fairly regular, like simply increasing or decreasing, or do they vary? Perhaps they increase, then decrease. So you're looking at the overall pattern of how your dependent variable is changing. The monotonic relationship, again, just be able to recognize what this means. The value of a cases consistently increases or decreases on one variable as the values of cases increases or decreases on the other. So they're both going in the same direction. This describes a relationship between moral beliefs and delinquency. So delinquency is more likely when moral beliefs are low, less likely when moral beliefs are medium, and least likely when their beliefs are strong. So it's you see how the pattern is changing. Our measure of association, this is the type of descriptive stats used to summarize the strength of an association. Now remember, we're looking at descriptive stats, so we're looking at the exploratory variables. Gamma is used with variables. Just be able to recognize what gamma is, that it is another type of statistic used. Inferential statistics are used in deciding whether it's likely that an association exists. Remember what we said a minute ago, in the larger population from which the sample was drawn, so that we know that our sample, the results of our sample analysis, can infer into the bigger population. You want to avoid concluding that an association exists in the population from which the sample was drawn unless the probability is less than 5%. And somebody brought this up within your discussion, which is really good, that you've got that p-value. So, and the p-value is your level of probability. And as a researcher, you can actually set that level to where you want it. You could set it at and see, look down here at the bottom where it's got, it's customarily reported to be p is less than 0.05. So it's translated as the probability that the association is due to chance. The chance is less than 5%. So it's 95% probable that one caused the other. And so, but you can also set it at 99. So you could set your p at less than 0.01. And you also see it in some that it's set at p is less than 0.10, which means that your probability is lower at 90%. And when you set these p-values, you do so within your software program, and then it will calculate it according to that probability. So statistical significance, you see this within your chi-squares. You also see it within your bivariate associations, and this is an association is not likely to be due by chance, so that the relationship and the changes in those are usually set by the actual independent variable. So the convention dictates that the criterion be a probability less than 5%, as I just said, that you want your p-value at 0.05 or less. And in a large sample, an association may be statistically significant, but still be too weak to be significant or important. And you'll see this with your own studies. And if you were doing your own data analysis, sometimes you will find that it's statistically significant. But then again, your R value is so weak that it's not important. It's not an important finding. But again, you still report all of that within your findings after you do your data analysis, which we're not doing in this class. So controlling for a third variable, now we're looking at a little bit more intense analysis. So there's different uses for 3-variable cross-tabulation. And so again, you're identifying an intervening variable, you're testing a relationship for spuriousness throughout your tabulation, and you're specifying the conditions for a relationship. So each of these uses for the 3-variable crosstabs helps determine the variability of our findings. And remember, that's really what we're looking at whenever we're doing our statistical analysis. We're looking at the variability because we want the variability to be low so that it's more statistically significant. Elaboration analysis. This is the process of introducing control variables into a bivariate relationship to better understand the relationship. So you might have just control variables that are you would put within, you might run a multiple regression that we'll talk about in a little while. But when you do your bivariates as well, you can have control variables. So we're talking now more into our regression and correlation. We're going from we're looking at bivariate and multivariate. So regression analysis is a technique for characterizing the pattern of the relationship between two quantitative variables in the terms of more linear equations. And we're looking at the strength of that relationship. And we also look at correlation analysis. And this is more of a standardized statistical technique that summarizes the strength of a relationship between two quantitative variables. So you're still looking at that linear pattern, but you're looking at the strength of the relationship. And remember, that's what's so important about data analysis and quantitative analysis, is that we're trying to see if there's any relationship within your variables. So if you've got your independent variable, let's say it's let's say look at juvenile offenders and recidivism. And so your independent variables are your juveniles, and maybe your juveniles placed in that are incarcerated, and juveniles that are in a boot camp. And then you're going to look at the recidivism pattern from those independent variables. And if there's no relationship whatsoever, that it doesn't matter where they're located, then you're going to find that it's not statistically significant, and it doesn't matter. You know, there's no relationship, so it doesn't matter whether you place a juvenile, whether you incarcerate them or put them in a community sanction. The recidivism rate is the same. And so but that's a finding. You're finding that there's no real relationship. And our correlation coefficient, as I mentioned earlier, are R values. You'll see this even within the meta-analysis. You see the R values, but you're looking at it from 0 to 1 or -1. So those values that are closer to 0, whether they're negative or positive, the relationship is weak. And so the values of R that are closer to positive or -1 indicate a strong relationship. And when you're looking at those negative and positive, it all depends on how you have set your R values within your data analysis. So the correlation coefficient does for a two interval ratio level variables what gamma does for the cross-tabulation. So it tells us the strength of the association. And remember, that's what's important after we find if it's statistically significant, what is the real strength. Our multiple regression analysis, this is when we're looking at more than two variables. We're looking at several variables. In addition, you have your main independent and simultaneously with your dependent variable, but you've got other variables that you're including as well. Multiple regression and analysis components. Here you have your beta coefficients that indicate the strength. Remember we talked a minute ago about the R and the gamma. So within multiple regression, you're looking at a beta coefficient. You don't really have to understand what that is. I know this is a lot and throwing it out to you, but I just want you to understand that when you're thinking about it, look at what a gamma it does, an R value, and your beta coefficients. So your R squared is a model fit statistic, and it tells us when it's multiplied by 100 the percent of the dependent variable's variation. That's explained by the independent variable. So we're leveling the strength of that relationship. And lastly, as we always do, we talk about our ethical considerations. Before I go into this, let me say that what we just talked about, and I know that it's confusing when you're hearing it, especially when you're hearing it from me, because I'm not able to answer your questions. But what I want you to remember mostly is go back here and look again. Is when we're looking at our chi-square, we're looking at here on the descriptive stats, you're looking at your gamma variable. Again, variable's value from -1 to the negative direction and to 0, so it means there is no association. And so the closer it is to -1 and +1, that there is an association. So, and then we look back here. Remember, I want you to understand what probability is, what your p-value is, what that means. It's checking for your relationship. It's checking for the strength, the probability that the association is actually that the change in the dependent is actually caused by the independent. That's your probability. Want you to make sure you understand statistical significance. As I said, we're looking at that p-value again. In regression, we're looking at the correlation coefficient, or your R value. So you have gamma for descriptives, you have your R value now for regression and correlation, and then with your multiple regression, you're looking at your beta coefficient. So I hope that's not too confusing. Now, lastly, let's just go over our ethical considerations. You have to always, as I said, whatever you do in your analysis, you just have to report it. So if you find that there's a skewness, you find that there's higher values, and you take them out, you report that within your results. And so, excuse me, you want to strike a reasonable balance between your deductive data analysis to test your hypothesis and inductive analysis to explore patterns. So you want to be honest about the limitations of using survey data to test causal hypothesis. You want to make sure that you report any findings that you have. And remember, finding something that's not statistically significant, that's a finding. That's telling us there's no relationship between those two variables, as I just stated. And you might be finding, if you're looking at your strength, you're looking at your gamma values and your beta coefficients and your R values, when you're finding that the strength is very weak, that tells us something too, and that's all reportable. You report all of that within your results. So within your own research papers, you won't have these strengths, and you won't have, you really won't even, when you're doing your methods section for your paper, you don't include any of those R values, because that's not important right now to what you're doing. You're only stating that, well, I'm going to use categorical variables, so I'm going to use a crosstab, or I'm going to look at a more linear relationship, so I'm going to use a regression analysis. That's what you need to understand right now within your own research. Hope that makes sense. Any more questions? Anybody has questions, please let me know, and I'll be more than happy to discuss it more and add any more that I can.